Now that we've looked a little bit at NAT, let's take a look at firewall rules. Let's filter traffic in and out of our firewall. We've invariably looked at some of these rules, but let's look a little bit deeper. So filtering or rules, which essentially forms the core of any firewall. So we get essentially L2 through 4, but largely L3 and L4 filtering with pFsense. And the rules can be interface specific. So for example, perhaps attached to the WAN or LAN or other, such as the optional interfaces, etc. So you can tie your rules to the appropriate interfaces determining the flow of traffic. So on the WAN interface, perhaps you allow specific ports, SSH, and other common ports, RDP, HTTP, NS, IPsec, other VPN-related rules, etc. Those would be considered specific rules, interface-specific rules, which apply to traffic in a particular direction, so directional traffic. There are also floating rules, and these rules apply to all interfaces, and in essence, they reduce redundancies because they allow you to define rules that are likely to appear on any interface once and apply them to all interfaces. So there's the notion of floating rules. And you can think of certain traffic patterns, such as the ports we've already mentioned, or maybe as simple as maybe Icmp. Permit Icmp, let's say IE, Icmp, echo requests, reply in any direction on any interface defined once as opposed to on a per interface basis. So it reduces the number of instances of Icmp related rules in that regard. We should also note that there is a default deny rule, and that's common across firewalls. This is implicit for all rules. Essentially, this means if a rule is not explicitly defined, it's not permitted. So, i.e., if rule is not explicitly defined, the traffic is dropped. And that we can see, and we've already seen by the inability to access our target system using SSH without first defining a rule. So far as it stands, let's take a quick look here in the firewall section at our rules. We permit, and this has kicked us out, let's fix this quickly, but we currently permit the common ports across our interfaces. Let's take a look here. So if not on this list, the rules will be denied. So as you can see, 80.443 to any destination SSH, and then specific rules for SSH and terminal services for destinations of 103, 102, 104, etc. So anything outside of these rules will be blocked. And we can clean things up by removing these rules and seeing how it behaves altogether. Rules are tied to NAT, so by natting a particular source or destination port, you invariably create rules to permit traffic for that particular rule. Now to delete rules, you just click on delete, or you can block and then select delete below to get rid of those items. So the selected rules, so let's say we want to wipe these out just to start anew. And these we can clobber, leaving 443 and 80 enabled to be able to access the interface. So let's apply the changes. So now the other ports are not permitted. How does that impact, for example, the NATs that have been placed on a port forward basis? Well, these port forwards are still there, but they currently have no rules to permit that traffic flow. So SSH should now fail, let's say, to the WAN address of 75.3, and that can be confirmed. Let's try to pull this up. 75.3, 22 fails. The same should apply to 22.22. That'll fail as well because there isn't a current rule in place to handle it. So firewall rules. Back to this for a moment. So these are directional rules, LAN and WAN. On the LAN side, any traffic sourced from the LAN using either of the protocols version 4 or 6 will be permitted. So that's permitted. We also see destination ports of 443 and 80 permitted, which allows, of course, access to the internal interface for the management of the firewall, as well as to any destination on the LAN for which there is a NAT mapping. And on the WAN side, we're permitting 80 and 443, which allows access to this management interface, as we can see. So long as there's a NAT rule that matches as we've already described, it's hard to talk about one without the other because they are intertwined. As long as there's a correlating NAT rule to a firewall rule, then traffic will be routed accordingly. Currently, there are no 80 or 443 rules, so all 80 and 443 traffic will be destined to the firewall. So if we refresh here 75.4, as you can see, it no longer serves traffic from the internal node. And in fact, 75.4 currently isn't responding to anything because it isn't mapped out. The WAN address is what's responding to the firewall rules of ports 80 and 443 currently. So with that said, what are some rules that are of interest? Well, let's say we start to set up what a real firewall should resemble in terms of the traffic that it permits. So for my local subnet, let's start with a broad rule which permits all traffic from 75.0. So let's say tasks create broad rule that permits, let's say, all traffic from 192.168.75.0/24 to anywhere on 192.168.1.0/24. So that's rather straightforward to create. Let's go ahead and do that. And if it's a rule that'll be matched most commonly, since rules are processed top down, you should place it at the top of the list, and that's common across firewalls. So since it'll impact the WAN side as it's connected to 192.168.75.0, we create a rule on the WAN side. Now if you click on any of these adds, the rule will be inserted below that existing rule. But before you apply the changes, you can always reorder the rule. So supposing this rule serves as your template, you can click on add, which will copy the rule, and then navigate through, and instead of any of the destination ports, just set it to any. And this will be any access. So any access from that 192.168.75.0/24 net. Now it places a rule there, but to move it up, you can select the others or select the existing rule and then move it above an existing rule. So let's say you pop it somewhere up here. So add a new, actually above one of these rules. So let's say we want to move it to this particular place above here. So move selected rules before this rule, and then it puts that rule there. And this will be an any access rule. This any access rule will obviate the need for 80 and 443, but let's just go ahead and confirm that. So now, any means we should be able to ping nodes on the inside. Let's see what happens if we try to send some packets. So we'll ping 192.168.1.102, for example. And notice it comes back. And let's see what happens if we try to ping from a different node. Let's say from this node, we'll ping C3 192.168.1.102. And actually, this one didn't come back. This initial item is not. It was a request timeout. It didn't come back. So why isn't this rule coming back? Let's see what we have here. Our rule for any access permits any TCP. So it's not broad enough because we duplicated it without setting all protocols. We set all ports, but not all protocols. So that said any. So it actually didn't come back. Let's go ahead and save the changes here. It should now come back as any once we've applied the changes. So that's any access. Now notice the ping works. Let's try this again from this side. It should now work. That looks good. And we can access any of the nodes that are routable, that are accessible. So 102, 103. And if we fire up the Windows box, so on and so forth, that's to be expected. That also means if we nmap, we should get a full registration of the nodes that are there. So 104 should come up, or 103, 102 will come up, 104 will not come up. And the open ports, Icmp pings will assist nmap in determining whether or not the nodes are up, and we should get a result momentarily. So this comes back rather straightforwardly. So that's a way that you can pass all traffic inbound. Now this inbound rule on the WAN side is independent of the rules on the LAN side. On the LAN side, any traffic can be sourced outbound. So that you can, from the inside, ping outbound is because of the LAN-based rule, which allows pings out, and the stateful firewall feature allows the Icmp echo response back in. So even without that rule, so for example, let's SSH to maybe 1.103, which is a BSD box. So from this BSD box, if config shows 1.103, if we send some packets to say 75.1, which is the default gateway, it comes back. And this is irrespective of this rule, the rule that we have on the WAN side to permit all addresses. For example, you can disable this rule. So clicking on this disables the rule. Apply changes, applies the changes. This rule no longer counts. It no longer matters. And if we generate that ping yet again, notice it still works. This is the stateful nature of the firewall. The traffic was sourced on the inside, on the LAN side. It met one of these rules on the outbound side. So any port, using any IPv4 or v6 protocol, including Icmp, TCP, UDP, any port, any destination, and it sent it out, and the stateful firewall allowed the traffic to pass back in. So this rule that we've created is not needed for return traffic. The stateful firewall automatically handles that. It's only needed from the perspective of the outside, where we try to access internal hosts, and there you can see it fails. And more clearly, if we try to ping something such as 103, it fails without that rule. But do we need an all rule? Perhaps we should have something that's more specific, like one that's related to Icmp. So we've created an all rule, so create all rule and test and remove. And B, let's say we create an Icmp echo request rule. This is more specific and it reduces the footprint. So let's generate a new rule. Now you can create a basic rule just using the add button, which isn't based on anything. We'll pass on the WAN interface using IPv4, but it could be IPv4 and IPv6. Protocol Icmp applies across both of them. Depending on what you've got configured, will determine. Then you specify what should pass. So it's an echo request. And by default, the reply will be permitted because it's stateful. And on the least, the LAN-based rule allows any traffic from the LAN side back to the WAN side. So either that or the stateful nature of the firewall will allow the return traffic to pass. So the source can be any, or you can specify a network to be more discrete, such as 192.168.75.0, just to narrow things in a bit, /24. That's always a good idea. In the event that you're breached, external parties are not able to Icmp echo request these internal nodes behind the pFsense firewall. And the destination can be any behind the firewall, or it can be the network itself, 192.168.1.0/24, just to be more specific, in the event that there are downstream firewalls, routers, etc. And it's always a good idea to log, but Icmp generates, along with other broadcast traffic, a lot of log entries, so this is something you'll toggle as you go along. So Icmp echo requests essentially pings. And this rule, if it's going to be a frequent rule, should be moved towards wherever it's likely to play an important role. So let's say we want it up here. Icmp echo requests will come through, apply changes, close this, and then let's try to send some packets in again from one of our internal nodes to 103. There are the echo request packets going in. And any node we pick, whether it's our local system or that system, it'll work. So if we maybe open a separate shell in this window here and send some packets over to 192.168.1.103 as well as 102, that works just because of that echo request rule. So you can break apart packets, that's not a surprise. And as we build, what about the other ports? We currently can't SSH, so Nmap proves that. If we try to Nmap the ports 80, 443, 22 off of anything in 192.168.1.0/24 or 100 through 120, that's the full range of addresses that are possible currently. It's really 100 through 104. So this shows, let's see what we've got going on here, that 192.168.1.0.24. Let's see what it's doing here. 100, actually what we want is 75 dot, because the routability makes it accessible. So it says that it's open. So for example, let's tell Nat, and we have to make sure we don't confuse it, to 1.102.80. So that's routing the traffic through. And let's take a look at our rules here. So let's just be clear about what's happening when we access 1.102 directly. 1.102 is accessible as a route through the firewall, not through the NATed interface. The NATed interface is always going to be a 75 address. So long as you have routed access into the network, you'll be able to gain access unless you have some sort of filtration. So there can be some confusion here as to how you're able to access, let's say, a particular target based on its local address, 192.168.1, versus its NATed address. So for example, we're able to connect to port 80 on 1102, but not if we try, say, through 75. One of the addresses that it could be mapped to, let's say 75.4. That's currently not listening. If you want to block traffic coming into 192.168.1 directly, you can set a deny rule for that and force traffic to go through the published 192.168.75 addresses. So that's another tactic, because we are routing, and the routing simply passes the traffic passing the firewall. The firewall is set to block traffic on its WAN network of 192.168.75, not for other networks such as 192.168.1.0. So for example, this gives us an opportunity to write a block rule. If we add a rule, notice block and reject. This is the same on Linux. Traffic that's blocked will just be discarded, and traffic, and it mentions it here, of course, and traffic that's rejected will issue a TCP reset or an Icmp port unreachable, which are gratuitous messages to the clients indicating that the item is not accessible, which indicates to the client, whether malicious or not, that the item's there, but it's being filtered. So a block is usually the best way to go, which just silently discards the packet. So the interface is the WAN interface. The traffic's going to come in on the WAN interface, IPv4. It could be any protocol, so you can just set this to any. And the source can be any, but the destination should be the network 192.168.1. And that can be specified by just indicating the LAN net altogether, which is 192.168.1. So that in the event, and this is an alias, by the way, so that if the LAN net changes, this rule will still apply. So let's say deny or drop, so either or, deny access to LAN addresses, or maybe LAN net. And that'll ensure, and if we place this somewhere towards the top of the list, so we'll just be sure that traffic isn't permitted by default, then you'll have to go through the NATed address for it to work. So let's say we bring this to here, and that'll be denied automatically. It'll force traffic because the firewall does see the traffic. So now we've got a deny on LAN net access coming from anywhere. But if you try through 75.0/ or the 75.some address, it'll work. So let's see what's happening here. 75.1.102. Now notice that 1.102 is blocking on port 80. But if we set up a mapping, let's say between 75.4, port 80, and that target 1.102, then it'll work. So that, of course, entails a NAT entry. So let's take a look at our NAT. Port forwarding, well, we're forwarding 22, 22, 22, and 3389. Let's add a new entry. And in fact, we can just base it on one of these. So let's say we take this one and change the port from MSRDP to SSH. And this one we have to double check it's mapping off to SSH from MSRDP. That's definitely an error. So what we want, let's say, is HTTP to HTTP mapping over to HTTP on a target of 1.102, which we'll get to momentarily. So this is going to be 1.102. Say HTTP access to 102. And that should be fine. Coming off of the WAN. And that's going to be on 75.4. Let's just make sure this is the WAN address of .3. We want it to be a specific address. So let's just make sure that we have that address. So because otherwise the WAN address itself, actually the address .4 is currently not available. Let's take a look here at our virtual IPs. We got to make sure that that's in place. It's not there, so let's add that again. We dropped it prematurely. So IP alias WAN 192.75.4. That becomes a /32, and no description necessary. That'll just give us a new address. And now 75.4 is available. And then back to the firewall rules for a moment. We can double up this address and then let that traffic in on port 80. So let's say we add, based on this rule, HTTP access, and the source can be anywhere, or 192.168.75.0, that's fine, coming in on the WAN, into a destination of the WAN address of 75.4. So let's just single host or alias. Let's make this 192.168.75.4. HTTP access on .4. Let's save the changes. And now we should have a rule with a target of 75.4. So as long as the NAT is there for 75.4, pointing to the 102 box, and we can double check that, firewall NAT on the WAN interface, port forwarded. We've got 22, 22, 22. Let's create a new entry here. We can create it based on maybe this one. And it's going to come in on the WAN interface, TCP. Instead of other, let's make that HTTP. And it's going to come in on 75.4, which automatically writes a rule anyway. By the way, you can just do NAT and it'll automatically write the rule for you. So you end up sometimes with double rules, but we'll see that momentarily. So into HTTP, and let's say HTTP into Linux CBT ubuserve 1. So let's click on save. So this creates a new mapping, 75.480, send it to 1.102. Close that out. Take a look at our rules yet again. And there we see a rule that's been written into 102 that correlates to the NATed entry. So let's see what happens now. We try to tell NAT to 102, where there's a block at the top. Now let's try to do the top of the rule set. Let's try to do 75.480. And let's see what it's trying to do here. Now it's being blocked. Now that leads us to some troubleshooting. So it's blocking 75.4 despite the fact that we have a NAT. Let's just double check. Unless our NAT is on 75.3, let's just double check that. It's on the WAN address. This one's on 75.4. So that's correct. So 75.480 is going to 1.102, but it's being blocked. And that's because of the rule that we have set. So this rule should allow it to port 80, but this rule is blocking it. So let's say for a moment we disable this rule. You can toggle it by disabling it, clicking on the apply changes. Now let's go back to the command line and try to hit 75.4. Notice it works now. So you got to be careful. When you create a NAT, a rule is created automatically for you. Now what if you try to hit 1.102 again? It lets it in. What if you try to hit something else? Let's say 1.103 on 80. 103 should be listening to 80 as well. It lets in it as well. Why does it allow 1.103 in on 80? So if you take a look at your rule set, any source, any port to 102, port 80 let it in. But anyone off of this network to any destination, port 80 let it in. So this is where we could tighten things up and say, well, if it's coming into 75.3, which is the firewall itself on 80, let it in. And for 443 the same. So that's something to consider. Let's go ahead and modify that. So what we want to say is instead of letting it into a destination of any, let it into a single address or to the WAN address itself, which is 75.3. That'll ensure that access, HTTP access to pFSense doesn't in a haphazard way allow traffic into port 80 to other nodes. So WAN address 80 and the same for 443. Let's modify these and we can move them together momentarily. So the destination should be the WAN address. And this will not break our access. It'll just tighten the configuration so that we don't allow inadvertently access into the wrong IP, so into pFSense. Again, one of the things with firewall rules, they become messy fast. So 443 and 80 for pFSense should be lumped together. So let's say we move this to here. These are both pFSense rules. This rule permits 75.4 access to 80. Because of the NAT, this rule is all that's necessary. But let's just apply the changes to see where we currently are. So let's see what happens when we try to access things. So we're going to try to hit 103.80. That fails. It just worked before. 102.80 will continue to work because there's a rule permitting that and there's a NAT. Then 75.3 we know works because we're connected to the pFSense interface. 75.480 works begs the question, which server are we on? Are we on the pFsense server or on the other node, which is the ubuserve box? We can test that from another window. Let's say in this window here, 75.4, refresh. This is Ubuntu. If it were pFsense, you would get a redirect to log into the page. So we've got two rules, 75.4, 1102 allowing 80. So what if we disable this rule, 75.4, and just leave the rule that was inserted by Nat, which is this rule? So let's apply the changes and see how the firewall behaves. We'll click on apply changes here. So the other rule is disabled. And over here, let's now try to get to 75.480. It still works. Implemented or method not implemented. We give it some time just to be sure it's not a fluke. And then 1102.80 still works. So what this tells us is that Nat auto-generates rules. So let's just note that Nat auto-generates rules. So check to ensure that you don't make rules redundant. And sometimes it's not clear because you'll see a target of the LAN IP address for the rule. But it does actually work. And what about blocking other nodes? As long as your existing rules are specific, the implicit default deny will block your rules. So again, block the other packet. So long as rules are explicitly defined, so i.e. sources, destinations, etc., then all else will be blocked. So you need to think carefully about how you write rules. If you write rules generically, you'll allow traffic to pass that you didn't intend. This still could be made more specific to indicate that the traffic should come from, say, a particular subnet. So we go ahead and edit it. And instead of any as a source, we want it to come from a particular subnet, such as, let's say, 192.168.75. But again, remember, this rule is associated to a NAT rule, so you can't edit the interface, the protocol, the source, the destination. You can view the NAT rule. That's one of the exceptions, by the way. And the NAT rule has a source built into it. So NAT, firewall NAT, and in this place you can then say the network that should be allowed to use this NAT rule. So 192.168.75.0/24 is allowed to use this NAT rule. So it's a little bit different with NAT rules. You need to do it through the NAT interface. So now that writes a NAT rule for 192.168.75. But again, that means, of course, anything upstream that doesn't rewrite the address to 192.168.75 will not be allowed to use that rule. So now let's take a look at our firewall rules. The rule has been rewritten. So let's just note this as well, that rules written by NAT must be updated via NAT interface. So NAT and firewall rules are tied together. And let's just be sure that we still have access. So we'll tell NAT, and there we still see 102, and let's try 75.4. Both are accessible. And as we bind other IPs, such as 75.5, they don't automatically become accessible. So let's say we tack on a new IP. We'll add a new one here, make this the following address, 75.5, as an IP alias. So it's a single address. No description necessary, just another address. So now 75.5 is presumably accessible. Let's try to access it, 75.5. Let's see what it does. We'll refresh it a couple times and try to punch that in yet again. So notice there isn't an explicit rule for 75.5. Let's close this out so the traffic isn't allowed. If you take a look at NAT, there's nothing that spells out 75.5 as a destination. We've got WAN address, which is 75.3. And let's just also note that as well, that the WAN address is the first address associated with the WAN interface. So it isn't the virtual or the additional addresses that are attached to the interface. So the WAN address is 75.3. The next address is 75.4, but there are no mappings to 75.5, neither one-to-one, outbound, or otherwise. And that's why the traffic doesn't pass. And also because we have rules that explicitly state the destination, along with NAT rules, then we restrict the flow of traffic into addresses that we subsequently add to the system. So these rules are becoming tighter. Sources are being have been specified. Destination 75.3 versus 75.4 versus 1.102, the actual address of the node. Versus this rule, it permits Icmp to anything. So if you try, say from here, send some packets, 192.168.1.102, that looks good. That's Icmp going anywhere, 103. And how about to the external address, 75.4? Well, the external interface doesn't permit Icmp by default. This, notice, is a rule for a destination of 192.168.1.0. What if you wanted Icmp to go anywhere? Well, you could edit this rule and just say Icmp echo request to anything. So for a destination network, just change it from network to any, or just maybe use a subnet of 192.168 to encompass both of the subnets. But nonetheless, let's see what happens here. So now we ping 75.4. Let's ping 1.103. And now Icmp is flowing for everything, 75.3, which is the actual interface of the router, etc. So that might be desirable, especially if you have monitoring tools that apply. And let's say update rules, D, permit Icmp to any, and that we've done. That looks good in tests, so we can ping anything now. And we can access 80 and 443 on the WAN interface. We can access 80 on 75.4 or 1.102. On 103, we may not, so let's nmap 192.168.1.103 to see what comes back. Icmp will know that the host is up, but if no ports are mapped, then we're not able to connect to them. We know the host has ports up, certainly. What about SSH? Well, SSH is definitely available, but unless you have a rule. So let's take a look at our mappings here. Let's close this out to see what's going on with SSH. Well, firewall, NAT. So 22 maps to 103. 22 maps to 102. A little confusing. And let's see if we have a corresponding firewall rule that allows 22 through. We don't. We've got Icmp, a disabled IPv4, generic IPv4, which permits all through. Let's get rid of this rule. This is just complicating matters. This gives any access to anywhere. That was a rule that we defined earlier. And here's a rule that permits anything to anywhere. Let's get rid of that anywhere rule and apply the changes. So to permit SSH now on both 22.22 as well as 22 itself, you need to have an associated rule to the NAT rule. When we created these NAT entries, they created rules. Let's just show that again. Let's get rid of these two rules quickly and just show that that's the case. So those two rules will be gone. So 3389, let's get rid of this as well. A little confusing for now until we bring that node on. Click apply changes. Let's take a look at firewall rules, make sure there's nothing for 3389. So that looks clean. So Icmp, HTTP, HTTPS to pFsense, and HTTP, and HTTP 2 rules, which permit access. And this one's actually disabled, so we can get rid of it. So we have HTTP access, NAT HTTP access to Linux CBT ubuserv 1. And before we do anything, let's just make sure it still works. So we'll telnet to 75.480. That looks good. And even if we give it some time, let's just make sure that it's not a fluke, because sometimes, depending on how many rules and the speed of the system and number of sessions, will determine whether or not the firewall responds in a timely fashion. And then if we telnet to 1.102.80, that comes up. So that rule still works. So everything's looking good. Now to tack on the SSH, the easiest way is to just plug in with NAT, which is why we covered NAT first. So you go to firewall NAT, port forward, create a new entry. You can duplicate the entry based on what's here. So let's say you do based on this rule, TCP off of 75.0, and the source can be anything because that's usually not known. The destination can be 75.4, and the destination port should be, say, SSH. So we'll start with SSH and map that into maybe 102, which is the ubuserv box. And that's going to go to 102 and redirect port to SSH. Make sure we match these up because it'll send you to whatever port is specified unbeknownst to the application. And then this is just going to be SSH to Linux CBT ubuserv 1. So this is going to generate a rule. Let's click on Apply Changes. So now we've got an SSH NAT entry. Let's take a look at Firewall Rules. And you should see the SSH NAT entry, NAT SSH. It prefixes it to indicate that's the case. And it points directly to 1102 coming off of 75.0/24. So we should be able to confirm that. 1102.22, that's going to come back with SSH. And then let's kill that and use the external address 75.4.22. And that works as well. So you can actually specify the LAN address and the firewall smart enough to know which one you mean. So that looks good so far. Let's see what else is of interest to us. So we've got SSH. What about the 2222 to accommodate the other node? Again, firewall NAT, or if you create a NAT, delete the firewall rule, recreate, etc. Just ensure that you have a correlation between the NAT rule and the firewall rule. So we do another port forward. We add it based on an existing one, but instead of SSH, this is going to be destination port. Well, it'll be destination of 22 on the target, so it's going to be 22, but the packet itself is going to be a different port. It's going to be 2222, so that forces our client to specify 2222. And this will accept traffic and send it into 103 in the event that we didn't have extra IPs. So SSH to, this is going to be Unix CBT BSD1, and let's pop that in, save the changes. So here's our SSH to BSD1. If the packet has 2222 as a destination, route it to 22 on the actual target. And that looks good. And then that populates the rules. Let's go back to Firewall Rules, and we should see a 22 access into 103. It looks a little bit off because it has a destination, the ultimate destination IP. However, from the shell, if you do a telnet here, 75.4.22, this is going to actually take us in. Let's see where this is putting us. This is going to be, let's take a look at the Nat Rules here. And we've got 75.0 into 75.4.22.22, and then 22. So let's see what we've got. Could be a little confusion. Let's try 22.22. And nothing's coming up here. Let's try the distinct IPs themselves. So 102.22, nothing. 2222. So the firewall's choking at this point. It's blocking. It's not matching the packet. So destination address 75.4.22.22 is our port forward over to 192.168.1.103. Sometimes this happens. Let's take a look at our firewall rules, whereby you make changes to the firewall list and it throws things off. Let's see what we've got here. It's actually taking a while to load. So 75.3, as long as we're not using the WAN address, we shouldn't have a problem. But it could be trying to reload the rules. Let's take a look at the interface itself from the perspective of VMware, just to make sure that nothing's wrong with the server. Sometimes when you trip these rules, you cause problems. Although we're only dealing with a few rules, so it shouldn't be a big problem. So what is this saying here? Runtime backwards, time issues. It looks like it's still good. We should be able to log in. So the server's still up, and if we can take a look at the logs, we should be able to see what it's doing. These are just packets coming off of the wire, so nothing there that's helpful. Let's log out. So let's see if we lose focus and go back if pFsense's GUI has been updated. So let's pop back over. It's actually saying it's not responding. And let's try to hit 75.3. So that rule must have thrown it off. If we try to hit 75.3 on 80, let's see what it does. It's not coming up. So the rule's throwing it off. Now, if we try from the other side, let's see if it responds from the LAN side. We'll be able to fix this problem. And we'll try from, say, ubuserve 1. And let's try to do an nmap v port 80 on 192.168.1.1. And so far, this is taking long as well. So we may have triggered a problem with the firewall because it's not coming up here as well. It should have come back by now. Let's telnet 192.168.1.1.80. Let's try 22. Well, 22 we know works. So there's a confusion on the port 80 side. It's not working as expected. So what we can do is actually reboot the firewall. Let's see if we can telnet into port 22. And that's not coming up. So just the console is working. So in this case, since we've confused the firewall, let's go back to console. This happens from time to time. Although we only have a handful of rules, if you change things quickly, under-resourced, etc., it can throw problems. So what we can do is reboot the system. And this will take a little bit to come back up, and it should reset the rules to the last or the most recent state. So it should work when it comes back up. So let's just give it a little bit, see if this helps out. Whenever the web interface goes kaput in this condition, then you usually have to reboot the firewall. And this is why it's advantageous to have multiple instances of pFSense. If you've got a spare VM instance dedicated as a backup in the event that, and this, as we see in this case, primary doesn't respond, the secondary should detect it and take over its IPs. So let's see what happens when we come up here. We were just trying to get some extra rules into the stack, so it shouldn't be such a problem. We just want to make sure we have all the ports that we need to communicate with those nodes on the protected network. And another thing we wanted to look at are the easy rules, where from the system logs, as you see traffic blocked, you can quickly generate rules to accommodate the blocked traffic. Let's see what we've got here. Web configurator is coming up. And once it shows the login screen, we should be able to try and get to the other side. Let's see what happens if we refresh. This should kick us back to the login screen. And let's see what the current rule set has to offer. So firewall, NAT. So 80, 22, 22, 22 looking good. And rules, let's see what we've got here. 22, 22 to 102, 103. That looks good. So let's try to connect as we were trying earlier. So 75 dot or 1.102.22.22, and that's not passing. Let's try 75.4.22. That passes. That's to Ubuntu. That's the first one. Now let's try 22.22. That's passing. That's looking good. So that's working as we expected. And then for port 80 on 75.4, that's passing. Excellent. So now it's passing the traffic onto 75.4, although the rule's written with the ultimate destination in mind, so you can SSH into the distinct nodes using the appropriate client. And from the client, if you do SSH with no options, you'll see that you can specify the port and connect to the target rather simply. So you just specify the port, indicate the target system. That's it. You can specify it as part of the IP, port, or just the P option. So SSH P 2222, maybe connect as root over to 192.168.75.4. Firewall gets that, routes it, and you can see there we're on BSD 1 versus if you connect to 22, this will just pop us into the Ubuntu box momentarily. So that's ubuserv 1. So the firewall is doing what it's supposed to do now. It was choking for a bit earlier. And then, of course, if a port is blocked, as we've mentioned, happens from time to time. So you try to access common ports 80, 443, 22, etc. The system log will show if those items are blocked. If you take a look at status system logs, for example, you'll see what's been blocked, and you take a look at the firewall. There are all sorts of logs in here, but you look for what's been blocked. And here we see some access points to 75.3 SSL, etc. And you can look for items that have been blocked, filter it on just the blocked items. And the latest items are at the bottom of the log. We'll spend a section looking just at the log, by the way. So here's some packets that have come in, UDP, TCP SYN packets on 22, but these are now permitted. So if we order them by time with no filtering, so by dropping block and just looking at the results, we should see the most recent entries towards the bottom have permitted access. But if a target, let's say our Winbox 3389 is not accessible, so let's fire that one up. We've got a node here. That's going to be Linux CBT Win 2. If we kick that one off, let's find it on the list. That comes up naturally with 3389, and it may not. The traffic should not flow through initially. Let's pop back over. We expect currently, and you're going to see a block, we can create an easy rule. As a firewall admin, you're looking at the logs often. If you see a block, if it looks like traffic that should be permitted, then you can create easy rules based on it. But looking at our nets, we've got 8022 and 2222, no 3389, which would be terminal services, no one-to-ones to accomplish those mappings. And in the rules section, it's just 2280, 443, and Icmp echo request traffic that's allowed. So what this means is if we send some ping packets from any of the hosts, local or our remote system, so if we ping our next host, let's presume it comes up with 104. That traffic will go through if it is 104. We don't know if it's 104 until we see the node come up. How do we know without even looking at the target system that that's the item? Just go to DHCP leases and see what the server's picked up. So the server claims it gave out 104. So good. This is giving out 104 at this time, 1801, and it's good until 2001. So it actually is 104. So let's see if we can send some packets its way. So now it's coming up. It just wasn't up at the time. So we can send ping packets through. But if we try to nmap it, we don't have nmap on this system, we'll do it on this system. So nmap, let's say ports 80, 443, 3389 on 192, 168.75, or 1.104, those ports will not be accessible. So you can ping directly using the routable IP, but you cannot connect to that particular item. Means, of course, we'll have to open up traffic to 104, and since 3389 isn't used by NICs, we can just use our port forwarding NAT. So back to port forwarding, you can base it on an existing rule and just change your destination port accordingly. So this becomes MSRDP, start and end, target 104, and be sure that your internal nodes reflect the same addresses, meaning that they don't alternate, and that can be accomplished. We'll look at the DHCP section using mappings, of course. So RDP to Linux CBT win2 and save that rule. Apply changes. This will create a firewall rule allowing 3389 through to 104, and then an nmap should come back with that 3389 port available. Now, it's accessible on 75.4, so let's just be clear on that. 3389 on 75.4 will come back as open. It also shows 80, but 80, when you scan an IP, nmap doesn't know that one IP is being split to multiple nodes. So 80 is open, 443 is open, and 3389 is open, leading to different systems. The NATs will tell you where they lead. So firewall NAT and any mappings to 80 should go to 102. 443, let's see where it's going. We don't have a mapping for that, so it claims it's open. Let's tell that. Actually, it's filtered, so it's not open. So it doesn't claim it's open. So now 3389 is open. That means we can presumably our desktop into that node. We should certainly be able to ping it, which we've already done, 1.104. And if we have a remote desktop client, we should also be able to get to it. Let's see what we've got here. Typically, there's an RDP client available, so let's see. Maybe we haven't installed it on this node, but the fact that we can telnet to it is good enough for us for now. We'll make the changes, ensure that we have an RDP client going shortly. And then if traffic's blocked, as we've mentioned, if you don't have a 3389 rule, it'll be blocked if you try to connect. So let's say you get rid of this mapping, RDP, apply the changes, have a quick look at firewall rules. The 3389 is now gone. You try to nmap it, let's say specifically 3389 just to save time. Although it doesn't save that much time. It's not open, it's filtered. You have a look at the logs to see what's been blocked. So system logs firewall. And we should see towards the bottom that 3389 was blocked. And one of the neat features of most firewalls is that you can just enable a rule on the fly. So this is a blocked entry. Blocked by default, of course, but you can, of course, create a rule out of it. You can reverse resolve or just create an easy rule to permit traffic. The thing about easy rule, let's just take a look at this. So easy rule block host WAN 75.101, actually from firewall alias. Let's double check this here. Let's try to create an easy rule. Actually, that's a block rule. We want to pass it. The thing about it is, look at how it writes the rule. It writes it specifically to a given host. So you may want to edit it to make it a little more liberal so that all of the nodes from that particular subnet are permitted. So 75.0, maybe 24. So just keep that in mind, 75.0/24. The easy rule pass will write it exactly how it was fielded, 75.4 MSRDP, and then the NAT should take care of it. So that writes a rule, 75.4 although the NAT would typically write the rule with the actual address of the target. So for example, let's try to scan it now, 75.4. It's going to look for 3389 to see whether or not it's open. Notice it says that it's not open. It doesn't come back as open because it's writing it verbatim. If you tell NAT to 192.168.75.4, 3389, notice nothing comes back. Why is that? Well, you have a firewall rule, but what you don't have is a NAT. So you look at your NAT, there's no NAT. So writing a firewall rule will not write the NAT for you. So sometimes you'll have to write the NAT manually. And if you write the NAT, writing the NAT writes the rule. So that's why writing the NAT is usually the better way to go. So 75.0, MSRDP. So just be mindful of the fact that you might write rules and notice that nothing's written, or that access is not permitted until there's a correlating NAT. That's fine, MSRDP. This is just going to be RDP to Linux CBT Win2. And then this will write a corresponding firewall rule. So you'll end up with additional rules, unfortunately. So here's another 3389. So this one will allow it, so you can actually get rid of this rule just to save some space. But the whole idea behind the easy rule is that if you see rules coming in onto IPs that should be permitted, you can quickly have a rule generated. It doesn't generate the NAT, it just generates the rule as it matches the log entry. So if you take a look at status system logs, firewall, as you see it is how the rule will be written, whether it's a block or a pass. So this was a block. You can actually write the block so that it doesn't show up again. Well, this is for UDP. If we go up here to 3389 somewhere, we should see it. But you can write it specifically. Here's the 3389. You can block it 75.101 as the source and the destination of 75.43389. Or you can just use this as a template and modify it accordingly to write yourself a quick rule. So it's just another shortcut. So a little bit about the rules. We're going to be, of course, oscillating between them as we move forward. Have a look at the dashboard, see how things are looking. And we're looking good. We're getting into pFSense administration.